Thomas Jagger, Scott Enderlead, and Brian Lowe. Thank you very much for the support. Got a real bird's eye view here looking down on our local area. Currently seeing a Pacific system moving out of New Mexico. And there it is, extending from about Trinidad, south to about Roswell and back to El Paso. Out ahead of it, I really need to start adding support for dry line in digital atmosphere. That's the dry line right there. So that's not really a trough. I'm going to see about getting that added in. Yeah, so anyway, south of there, dew points in the mid-60s. North of there, much drier conditions with lots of 30s and 40s. And another thing that's really significant is the temperature. Let me outline the area of 90s. So there it is, a broad band of 90-degree weather. Hottest temperatures, probably 95 there at Childress. So that's a combination of downslope, subsidence, and just very intense heating for this time of year. And it's also the dry air, since dry air has a very rapid amount of warming and cooling. And you can see where we transition to that cold front. We can use the imaginary car drive. Let's go along Interstate 70. You can see there in Oklahoma City, we start at 92 down to 86 at around Clinton. Yeah. 90s in the Panhandle. We get out towards, let me bring up the plots there. Looks like 85 degrees there, Tucumcari. Then it starts cooling quite a bit. We get down to about 75 there at Santa Rosa, and then it cools into the 70s and 60s. Now, some of that is because it is the higher terrain, but Albuquerque there, 64, rain. That's got to be, yeah, that's got to be our front. And one thing that we can do is plot the potential temperature. That can help us out a little bit, so let me find that. So there we go, kind of a very gradual transition as we go from the thermal axis back towards the west. And I can pick out kind of a stronger gradient west of central New Mexico back in this area. So this is another potential analysis. Is this possible? Cold front further back to the west? Well, I don't know, because then we've got that 64-degree reading there at Albuquerque. Some kind of cool temperatures up in that region, and they're also cold. And I think this time of year I would like to see 70s if we were ahead of that cold front. Now, there is 79 there, truth or consequences, so I don't know, this could be maybe a cold pool from some of the convection in that area. Now, another thing we need to look at is moisture. Because when you get back into some of the Pacific air, sometimes that Pacific air tends to be a little more humid. I can see dew points in the 30s here, and it's about the same on the other side. Okay, no help there. Where else should we go? How about the satellite? Yeah, we should see differing cloud forms on one side of the front and the other. A lot of high cloud and a lot of mountain wave activity. That'd be a rough afternoon to be flying from Arizona out to New Mexico. Don't see any low cloud fields, so yeah, not a whole lot of help there. We do see that, hey, I managed to draw the state of Maine. Okay, no, the large area of cumulus is in that area, so maybe those temperatures out ahead of there is from a combination of evaporative cooling and cloud cover. So yeah, this is a very tough one. So yeah, let's take a look at Albuquerque and check out their weather. This is, we can use METAR trends to find wind shifts and changes in the weather, air masses moving through. So let's see, Albuquerque, they started out at about 59 degrees, warmed up during the morning. If we go up, that's increasing time. So let's see, winds were kind of light out of the south. They came up to south at 23 in the late morning. And then they switched around to 260 at 16 gusting to 34. Las Cruces, about 74 degrees, 73, 74. Winds shifted very slowly around to the southwest, and they're gusty. pressure, that's an important thing. Let's see, we dropped 29.98 down to 29.92. So it's it's a gradual drop off there. You know, guys, I think that front is to the west. I'm not 100% sure, but I think it probably is, like I've got it right here. And I'm going to assume that this is just kind of convective cold pool. So I would like to see the temperatures a little warmer in this area, but still, that's pretty good. And you can see we go from 79 at El Paso, and then we fall off to 60 at Tucson, 57 out there in Safford. So I'm going to go with that for now. Let's see if we can get some help from weather nerds there. Let's pull that up. Yeah, and they've got high-resolution rapid refresh cross-sections. Wow, okay. That'll be pretty neat. Okay, let's get a cross-section. Let's go from Phoenix. We're going to go across Las Cruces to Midland. Let's give that a shot. Get cross-section. So neat having all this new technology, and I feel sorry for Europe and Asia where there's just not this kind of innovation. We've got some fantastic tools here in the U.S., and I think we're just kind of reaping the benefits of free exchange of weather data. All right, so A to B, down there in the inset, A is Phoenix, B is Midland. It looks good. So we know that the west is the left side and the east is the right side. Okay, you notice something here? Okay, well, first of all, we're at 19Z, so this is going to be early afternoon. And I do see a front right there. See those three isotropes? And then there's pretty much nothing out here. It's very spread out. So I think this is the Pacific front, and you can see I can follow that up to 700 millibars, up and over Phoenix. That's it, I'm pretty sure. And this is really neat. Look at that wave. I'm not so sure that that's an artifact or anything. I think maybe the high-resolution rapid refresh is modeling that turbulence, that wave action there in the mid-levels. So yeah, we've got our front out to the west. What other cool stuff can we find? Let's go back and do another cross-section. Go back to zoom mode. I'm going to do this one from... Let's try going from west of Tucson across Albuquerque to La Junta and up towards Russell, Kansas. Let's do that. So that should cut from the cold air mass into the occlusion, or into the, no, there's no occlusion, to the low and then over to the heat low and lee side trough in Colorado. Let's see what that looks like. Okay, this is pretty cool. So yeah, they're checking out the cross-section. Everything looks good. And I can see our front there getting ready to cross the mountains. Out ahead of it, we can see some evidence of the wave action, since this is likely picking up some of the mesoscale detail. You can see some warmer temperatures here where the isotopes sag down. That's warming. So maybe we got a little bit of adiabatic warming in the lee side of this first mountain. So that's going to be probably around the Safford to Silver City, New Mexico area. I think that's what that is right there. And then we come around to the other side of, that's probably the front range of the Rockies right there. Then we get around La Junta. And then as we get out towards Kansas, we can pick up that other front that's anchored down there in Kansas. We can see that that's, you know, a pretty shallow front. Probably goes like that, just barely above 800 millibars. I got an idea. Let's try transecting that dry line. Let's do a line from Houston across the dry line in Wichita Falls and up to Denver. Wow, this is very cool. And you can see the higher relative humidity down in the tropical air. Let me try bringing up dew point. Well, looks like we don't have dew point, but we do have the RH. Okay, so it's somewhat useful. And so that right there is the cap where we have the bunching of the isotopes. That's an inversion. Let me show you what I'm talking about. Let's go to pivotal weather. So there's pivotal weather. We're going to put it right there in the tropical air. And there you can really see the tropical air topping out at about that level. Above that is the dry EML. Very warm there. It warms all the way from about 20 Celsius up to about 23 Celsius. And for that level, that's pretty warm. This is a very strong cap. So we're definitely not going to get any severe weather. In fact, if I try to compute the convective temperature, that goes all the way down to about 43 to 44. That's going to be about 115 Fahrenheit to get convection. Now, if we did get convection, yeah, we'd have some serious severe weather, but this is a classic example of the warm elevated mixed layer, and then above that, some of that higher relative humidity, some of those clouds up at about 18 to 20,000 feet. And that's what we're seeing right around here. That's some of that mid-level cloud. So here, classic presentation of tropical air. And then the dry line is about right there over Wichita Falls. Then when we get out in Oklahoma, very warm, dry conditions. And then we start picking up some of that elevated stuff out in Colorado. There's the situation across the southeast U.S. Again, remember that this is a dry line. It's not a trough. It extends all the way up into Joplin, Missouri. Little wedge of dry air going up in that area. South of there, we've got southerly flow. And that's a very modest southerly flow. We saw on the cross-section there was very little evidence of a low-level jet. However, we do have that warm front. It's all the way up in Illinois, Kentucky, and looks like it's hung up a little bit in the South Carolina, Georgia area. There's how things look in the southeast U.S. Looks like an old decaying area of thunderstorms there, just south of southwest of Fort Worth. And that's about it. It looks pretty dry. Fair skies all the way back to Georgia. And we have to keep in mind when we try to interpret this chart, got to think about the frontal position. So we've got something like that going on. So that front is just about completely dry. And you can see in North Carolina and Virginia, up at the top of the chart, some evidence of that cold air damming that we've got in that area. See that area of stratocumulus? The western fringes have got some evidence of terrain. Yeah, terrain interaction. That's that easterly flow advecting upslope and hitting the mountains there, and that's some trapped moisture and cool air that's not able to clear the Piedmont area of Virginia and North Carolina. There's how things look in the northeast U.S. Very broad, but also very weak. 10, 18 millibar high up there in Ontario. Let's see. Yeah, there it is. That's driving a little bit of cool air down into the Great Lakes region, giving us some 30s and 40s in that area. A little cold front coming across Lake Erie and Lake Ontario. And that's just weakly reinforcing that system there in Missouri. Very nice day in Pennsylvania, West Virginia. Got some fair conditions in that region. And let's take a look up in the Pacific Northwest. There's how things look in that part of the country. The big thing that I'm seeing is the push of Pacific air into the northwest. See that big high off to the left side of the screen? That's a big chunk of Pacific air coming inland, and that's helping to drive that Pacific front moving through the Rockies right now. Due to the very zonal pattern we have, we've got a lee side trough extending from Alberta down to Montana and Wyoming. And with that, we're getting some good downslope flow, some warming, good conditions, lots of 40s there in Montana. Yeah, and about the highest I'm seeing right around 45 to 46 in the Billings area. And the Interstate 80 corridor in southwestern Wyoming has been in very bad shape, so we really do need that warm-up. This is how things were looking around Bear River Drive near Evanston, Wyoming, and it looked really treacherous about 5 or 6 hours ago. Things are picking up, but you can see how the traffic is very light in that area. I guess they're just now getting it going. I like that. Be COVID aware. Dial 211 for info. Seeing it everywhere, even on the traffic cameras. So, yeah, let's head into our forecast. With that very powerful Pacific system coming out in Mexico, I don't want to use the GFS quite yet. Let's see what's going to happen for the rest of the afternoon. Well, some erosion along the dry line, but one thing that I'm noticing is that moisture is really surging northward there in Oklahoma. Let's see what a sounding looks like in the northwest edge of that moisture, say around Watonga, Oklahoma. There comes the sounding, and we are still capped. There's some capping there, and the other problem is that the moisture diminishes with height, which means it's going to mix out very easily. We don't want to see that. We want to see that green line standing up vertical. So that's right there is going to be a problem. Now, the wind profile actually does look pretty good. So if we were able to squeak storms out of this, we would have the shear in place. That's a classic. Yeah, you see that amount of area swept out from 0 through 1 kilometer from the storm motion vector. That's a lot of shear that can be converted into streamwise vorticity there. One thing that's interesting is if you advance this up to 2122Z, you can actually see the front. See it right there? So I really like this dew point product because I can see all the air masses at once. So that's the front, and then the dry line is going down like that. So if we were expecting storms, we would want to be just west of Enid in that triple point area right there. So as the evening goes on, we do get some moisture surging northward, but it's too little, too late. There's 4Z, 5Z. We could still get some forced convection, but I'm not really seeing that. Maybe one little cold pool right there. This is not breaking out convection. Let's go to the actual reflectivity. See what that does. There's that high base convection around Taos and Clayton, but nothing in Oklahoma or Texas. So stick a fork in it. We are done. But a classic dry system. And then it looks like tomorrow morning, model going for maybe a little bit of elevated convection right there. Let's see, that would be around Stephenville, Dublin, up to Eastland, Texas. So we'll keep an eye on that. See what the soundings look like for that stuff. Yeah, that looks elevated. It's probably this layer here being released. So let's jump into the GFS. This is how things are looking to me, right, for this evening. There's that cold front coming out of New Mexico there. In between, there's the post-dry line air, and then more moisture coming northward, but we're just too capped to do anything with it. And that stationary front will be up along the Kansas-Oklahoma border. And most noteworthy is that cold core low there in California. Probably a little bit of showery activity this afternoon. And then let's check out tomorrow. Yeah, see, this is interesting. The front is still not out of the Rockies, so that definitely supports my westward placement. There's our front. Looks like it's reconsolidating there in Colorado and Kansas. Main cold core system out there in the central Rockies, back there in Utah and Arizona. And I'm not too sure where the dry line is. I'm inclined to think maybe it's something like that. Let's take a look at the dew point real quick. Okay, a dry line from Del Rio to east of Abilene and up to Oklahoma City. The dry line will look something like that, and we'll just take a quick check of the sounding in that moist air to the east of there, and it looks like we're still capped. If we got some really good localized forcing, we could probably break that. But I don't know, it's kind of a, you know, I don't see any like good pressure falls down in this area. So I'm not sure we're going to be able to squeeze forcing from the lower levels out of this. And the phase of this system is not very good. See, this is 0Z. This is evening, and this front is starting to come out into the Great Plains. We want to see this in the morning, not the evening. See, that way things warm up, and then we find our boundaries out here, and then boom, we get convection. So this is all bad. I mean, if you're a chaser, it's bad because there's not going to be anything to see. So by the time it rolls out into Fort Worth, Oklahoma City, it's nighttime. It's cool. And there it is, just kind of blowing eastward through the Dallas area, through Tulsa. Getting a well-defined boundary up there in Ohio, Illinois, and Indiana. And you can see a little bit of forced convection start to break out there. And then let's see, we finally get our heating as things roll eastward. And then by Saturday evening, we've got convection. Maybe things finally start to come together. Illinois down to Memphis. So that looks like certainly some severe weather potential, but the best possibility for that is going to be along this warm front. So this could be kind of a very treacherous day for Chicago, depending on how this works out. And then back towards La Crosse and Minnesota. There's our occluded front. Then for Sunday evening, everything rolls to the northeast. Start getting some showers and storms there in New England. Back behind it, lots of high pressure coming into the lower Mississippi River Valley, and that looks like it extends all the way up to Manitoba. So lots of good weather across the central U.S. Things are destabilizing out to the west again. See, there's another upper-level low. Got a very showery appearance out there in the Great Basin area. And that front, the remains of that front are still out there in northwest Mexico. So that area is still going to be baroclinic and supporting this upper-level southern stream jet. So that gives us one more shot at some storms for Monday midday. And this looks kind of like a warm front episode. So there's our boundaries there for Monday. Depending on what the instability is like, this could be a good Red River weather event. Let's see what the forecast soundings show. I don't know, not very much instability. Looks moist adiabatic there. However, that's some fantastic 0 to 1 kilometer shear. So it really depends on how things shape up. But we'll have to keep an eye on Monday. Yeah, see right there, good 0 to 1 kilometer shear. Not a whole lot of instability, but you really don't need that if you have enough shear. All you need is to get some good deep convection going, and everything will work itself out. The other problem that I see looks like a lot of upper level moisture. Let's see what that's doing. To look at upper level moisture, well, let's see. There's a couple products here we can use. .200 millibar relative humidity. Yeah, see, there's how things look during the day on Monday. Good plume of tropical moisture. That's going to cut down significantly on solar heating, which means we're going to kind of be depending on mesoscale accidents to get any severe storms going. From a chase perspective, if we're storm chasers, we don't want to see that. That means a lot of gray skies, maybe fast-moving storms when you're underneath that jet. To check on the cap, we pull up to 700 millibar temperature. Yeah, the cap is not going to be too strong. Our sounding did kind of confirm that. You can see the 700 millibar temperatures are right around 4 to 5 Celsius. So that's not going to be a problem. This kind of maybe points towards maybe some squall lines or multi-cell clusters. We'll have to see, but you can see there out to the west, looks like a lot of cold air about to filter into the area. So destabilization is definitely going to be ongoing on Monday. Well, thank you for watching the webcast. Again, thanks to our new Patreon subscribers. And we'll have one more day of a regular weathercast, and then we're going to do the supporters only stream over the weekend. Okay, well, that's enough panhandling for today. Sorry about that. We'll see what's going on with the system tomorrow, which we'll check out West Texas and see if anything has changed. Anyway, take care and stay healthy. Please follow your precautions there, social distancing and all that, and we will see you tomorrow. Bye-bye.